Welcome to The Explainer. Today we're diving into a massive challenge facing modern investigators. How do you seize evidence when the crime scene isn't a hard drive you can hold in your hand, but a server you can't even see, running somewhere out there in the cloud?
And really, this is the question at the heart of it all. For decades, digital forensics was pretty straightforward, at least in concept. You seize the hard drive, but as crime has migrated from desktop PCs to data centers, and now deep into the cloud, the entire playbook has been rewritten. The core rules haven't changed, but how they're applied? Well, that's a whole new world.
So, here's our game plan. We're going to start with the fundamental principles that never, ever change. Then, we'll trace the evolution of data acquisition, starting with physical machines, moving to virtual ones, and finally jumping into the cloud with AWS and Azure to see just how much the job of an investigator is transforming.
Okay, first things first. Before we can even talk about the cloud, we have to ground ourselves in the basics. Because no matter how fancy the technology gets, these rules are what separate a valid, solid investigation from one that gets completely thrown out of court.
Simply put, data acquisition is just the official term for grabbing digital evidence. The goal is always the same: get the data in a way that's verifiable, repeatable, and can stand up to scrutiny. It's the how we do it that has changed so dramatically.
And these right here, these are the absolute non-negotiables. You have to document every single thing you do. The original evidence must never be altered, period. You prove it wasn't altered using cryptographic hashes, and you track its every move with a chain of custody. Without these, any evidence you find is basically worthless.
All right, let's start with the classic scenario: a physical computer sitting on a desk. This is the foundation, It's the baseline that all other digital forensic techniques are built on. It's our gold standard.
Now, the key concept here is the bitstream image. This isn't just dragging and dropping files. Oh no. This is creating a perfect, identical twin of the original drive, down to the very last bit. It captures everything, even the stuff that's been deleted. This idea of a perfect replica is the goal we're always chasing, no matter where the data is. And the process itself is very hands-on. First, you use a physical gadget called a write blocker, which acts like a guard to prevent any accidental changes to the original drive. Then you plug it in, create that perfect image, and run a hash check to prove, mathematically, that your copy is identical. It's a very tangible, hardware-driven procedure.
To get this done, investigators rely on some specialized software. You've got tools like FTK Imager that give you a nice graphical interface, while powerful command line tools like DD are built right into Linux and macOS, offering a scriptable way to do the same job.
Okay, now things start to get interesting. We're taking our first step away from that physical hardware and into the world of virtualization. This is where the line between hardware and software starts to get really blurry.
And here's the crucial shift. With virtualization, the hard drive is no longer a single object you can unplug and hold. Nope, it's now just a very, very large file, a virtual disk. The investigator's target has officially changed from a piece of hardware to a piece of software.
And now for the biggest leap of all, into the cloud. Here, the crime scene exists on hardware owned by Amazon or Microsoft or Google, scattered across who knows how many data centers. The investigator has absolutely zero physical access.
This table just lays it all out, doesn't it? The difference is night and day. Forget plugging in a SATA cable, now you're making API calls, which is basically sending a command to the cloud provider's software. That hardware write blocker, it's replaced by a software command to create a snapshot. And maybe most importantly, the investigator's total control is gone, replaced by a partnership with the cloud provider.
And this all boils down to what's called the shared responsibility model. The cloud provider, they're like the landlord. They secure the building and the physical servers, but you, the customer, are responsible for what's inside your virtual machine. So for an investigator, this means you have to play by their rules and use the tools they give you.
Okay, so let's get specific. Even when you're in the cloud, it's not one size fits all. The exact playbook an investigator follows is completely different depending on whether the evidence is sitting in Amazon Web Services or Microsoft Azure.
In AWS, the process kind of feels like you're managing virtual hardware. You isolate the machine from the network, take a snapshot, which is their version of our bitstream image, and then you use that snapshot to create a brand new virtual hard drive. Then you attach that new drive to a clean forensic workstation, all inside the AWS cloud, and mount it as read-only.
Azure's approach is different. It's less about moving around virtual hardware and more about secure data transfer.
You still create a snapshot, but your main goal is to generate something called a SAS token. That's essentially a secure temporary key that creates a one-time download link, letting you pull the evidence directly out of the cloud and onto your own forensic machine.
So this huge shift from physical control to remote procedures doesn't just change the workflow, it creates a whole new class of challenges that, frankly, didn't even exist a decade ago.
I mean, think about it. If a server is in Ireland, but it's being accessed from Brazil, which country's laws apply? It gets complicated fast. And evidence isn't in one neat place anymore. Logs are scattered across dozens of different cloud services. Plus, if a log file is set to auto-delete after 90 days, you're literally racing against the clock. These are the complex puzzles that define modern cloud forensics.
And this leaves us with a final thought to chew on. The skills that made a great investigator 10 years ago, knowing hardware, understanding disk structures, are being replaced by the ability to write scripts, to query APIs, and to navigate these incredibly complex, software-defined worlds. The tools have changed, and so has the investigator.